Hi, this is Brian Kim. I'm going to share with you case number 113 in the Best Way to Do Cataract Surgery series. This is the 3 to 4 plus dense lens, and I'm going to perform double chop, cross chop, and you'll see mechanical fracturing techniques. And I'm using sparing amounts of ultrasonic energy, systematically breaking the lens down, using the two instruments to crush it into smaller pieces, and then emulsifying the lens pieces. By doing it this way, this is very controlled. This uses less high vacuum, less ultrasonic energy, and just controlled pulses of those things. And as a result, I have less risk for complications and clearer corneas post-op day one. So I'm using a cotton tip to steady the eye, and then I'm using a corneal marker, which will help me to center and size the rhexis. Using that same cotton tip, I'm controlling the eye for the paracentesis incision. So I make an incision first on the right side and the left side, and then make sure the incision is parallel to the iris plane, which creates a nice corneal shelf, which will allow me to achieve a self-sealing incision. This is intracameral lidocaine, and then some dispersive viscoelastic to fill the anterior chamber. And this is the triplanar corneal incision. I make a vertical groove, place the blade into the deep part of the groove tunnel, use a cannula to turn the eye toward me, and then I enter. I push some more viscoelastic to fill the chamber. And this is the puncture style rhexis. Using the forceps, I'm going to puncture the central capsule. I wanted to pull down towards me, but the tear went to the right, so I'll go ahead and go with it. Grab the right side of the tear, and then create a flap going around circumferentially, trying to follow the mark I made before, which will hopefully allow me to achieve a well-centered and sized rhexis. Burp the viscoelastic out, and this is the capsular fornix hydrodissection technique. Place the cannula under the rhexis edge contra-incisionally, point the tip down, get a nice wave, decompress carefully on the left side, point the tip down on the right, hooking the peripheral lens, and the lens begins to spin. This is really a no-fuss hydrodissection technique. It really makes it very easy, very consistent to hydrodissect and spin the lens. Irrigate the surface of the eye, lifting the incision with a chopper, going in with irrigation off to minimize Descemet's trauma, removing the surface epinuclear material, placing the chopper under the rhexis edge contra-incisionally, the phaco-tip vertically sub-incisionally, bringing the instruments together and fracturing the lens in half, placing the chopper around the right heminucleus, pulling it towards the phaco-tip, crushing it against the phaco-tip, and dividing the right heminucleus. Using some vacuum to hold that first quadrant, and then crushing the lens between the instruments, using some vacuum to lift that piece up out of the bag, going after the second quadrant, pulling it towards the phaco-tip in a cross-chop manner, grabbing that fragment with some vacuum, and then crushing the lens between the instruments, and then emulsifying the lens pieces. Using the chopper to hook that last fragment up from the second quadrant, fracturing it, using some vacuum to lift it up, fracturing it again, and then emulsifying the lens pieces. Rotating the second heminucleus in front of me very carefully, placing the chopper around the lens piece, pulling it centrally toward the phaco-tip, dividing the lens in half, making sure they're completely separated, placing the chopper around a third quadrant, crushing it against the phaco-tip again with a cross-chop maneuver, crushing the pieces into smaller pieces, and then emulsifying the lens pieces. I really need to publish some studies on this technique because unless you do the technique, you really have no idea. And really traditional chopping techniques and sculpting techniques really cannot hold a candle to this technique. The ultrasonic energy use is just a fraction of what it is with the traditional techniques. And those people who say, well, it doesn't matter how much ultrasonic energy you use as long as you coat the cornea, unfortunately, those people don't have any idea what it really means to use low amounts of ultrasonic energy in the context of very, very dense lens. Sometimes you can't get clear corneas even though you coat the cornea with viscoelastic. You can use tubes and tubes of it, and still you can have corneal edema. But I've noticed with this technique, if you follow the principles, you have consistent clear corneas with dense lenses. And I've been made a believer after having done this technique over thousands and thousands of patients. So the fourth quadrant has been removed, and now I'm very carefully removing the epinuclear material. I take the chopper out, push BSS in, take the phaco tip out, and I go in with the INA handpiece. The INA tip grabbed that bulk of epinuclear material and cortical material from posterior, so I refluxed it out and then tried to re-grab it again. By grabbing it anterior, it's just a cleaner pull. Sometimes you can't help it and the posterior stuff wants to come up. If you do that, you're going to have a higher tendency to have some very fine cortical wisps that are remaining. So I switched to polish mode and I'm polishing under the rexus edge, and I'm grabbing some of this adherent cortical material that's still left behind into the fornices. I'm polishing subincisionally as well. Invariably, there's some adherent material there, especially when the cortex didn't come off cleanly. I'm going to pulse into the subincisional capsule fornix, and you saw there's some stuff there. So yeah, I mean, whenever the cortex doesn't peel off cleanly, you'll have more of these fine cortical remnants that you have to look for. Fill the capsular bag with cohesive viscoelastic. I start to sweep under the rexus edge. As you can see, as I'm sweeping subincisionally, there's more stuff that's coming out. So that's the other benefit of sweeping. You're able to polish lens epithelial cells, but you're also able to get some stubborn wisps of cortex that are harder to reach. So this is a single piece acrylic lens. I'm going to inject into the capsular bag, the leading edge at least. And then I'm going to quickly transition to the INA as the lens unfolds. Go in with irrigation off, activate irrigation, make sure the haptics are disengaged from the optic, go underneath the optic, tilting it and rotating it 90 degrees, clockwise, removing the viscoelastic from within the bag. Switching to polish mode, polishing under the rexus edge a little bit more. Turning the lens a little bit. Switching to visco mode, removing the viscoelastic from the anterior chamber, and then I'll hydrate my incision. So again, this is a fairly dense lens, about a 3 to 4 plus lens. I use mechanical fracturing forces to crush the lens pieces. Again, critics would talk about, well, I don't see the benefit. Aren't you causing zonular damage? Unfortunately, those critics are people who have never done the technique. If you've done the technique and you know what it feels like to grab the lens, then you'll be able to appreciate and understand what's actually happening here. So you're not causing zonular trauma, you're not causing any issues, you're bringing the instruments towards the center and crushing it with the instruments. That's the power of this technique and the reason why it's different from all the other techniques. And again, this is why I feel like this is the best way to do cataract surgery. So I hope this was helpful to you, and I thank you for your attention.